Okay, sorry about the delay. I am finally home, and we will take a look at the example we were doing in class today. So it was copper metal in an acidic potassium permanganate solution. So copper metal is going to be Cu solid. Acidic is going to be H positive, aqueous. Potassium, K positive, aqueous. Permanganate, MnO4 positive, aqueous, and in solution, H2O. Okay? And now you need to find each one of these on your table of redox reactions. Okay? And you need to see, are they on the oxidizing side? Are they on the reducing side? Where are they? So the first one we're going to find is copper, and when you find it, it's on the reducing agent side. So we put an Ra here. Then when you look for H positive, you'll see it in a number of places. The only two that we can use are the one where it's linked to the permanganate, and it's an OA, and then it's there by itself on the OA side as well. It's in a bunch of other reactions, but it's with things that we don't have, so we can't use it because we don't have those things. All right, if you look for your potassium, it's at the bottom on the OA side. If you look for the permanganate, the only place it is where it's linked with the H positive. Okay? And then when you look for the water, sorry, I'm getting a reflection here and I can't figure out from what. When you look for the water, you'll find it on both the OA side and the RA side. Okay? So we've listed all our entities, and now we've identified them all as oxidizing agents or reducing agents. The next step is to see which one's the strongest oxidizing agent. To see that, you go back and you look at each one of these that we've put in as OAs, and you check to see which one's the highest on the table, because the strongest oxidizing agent is on the top. And the one that's the highest up is the one that's linked, the hydrogen ions linked with potassium permanganate. Okay, then you do the same for the reducing. Which one is the strongest reducing agent? For reducing agent, it's going to be which one's closest to the bottom, because that's where the strongest reducing agent is. And so when you look at the two reducing agents, the copper is closer to the bottom. So you put an S in front of that for strongest reducing agent. And now all we have to do is write our two half reactions, and we write them exactly as they are on the table. Okay, so find the potassium, the permanganate on the top. So it's MnO4. Oh, I think I put a positive up there, but it's really a negative. Sorry, negative, aqueous, plus 8 hydrogen ions, plus 5 electrons, going to Mn2 positive, aqueous, plus 4 water. Okay? So that's one of our two half reactions. The second one is with copper. And now it's the copper solid that we have. So even though it's written the other way around in the chart, we have to start with Cu solid, because that's what we have up here in our entities. So it's going to be Cu solid going to Cu2 positive aqueous plus 2 electrons. So you just write it in reverse. Notice on the table the arrows are going in both directions, so you can start on either side. Now we use the steps like we were using the other day. Okay? The half reactions are already balanced charge-wise and entity-wise, but if we want to add these together, we have to balance our electrons. Notice they're on the opposite sides of the equation, which they should be, because if we're going to add these together, we want our electrons to cancel. So we're going to need to multiply the top equation by 2. That'll give us 10 electrons on the reactant side, and the bottom equation by 5 to give us 10 electrons on the product side. Now that we've done that, we can add these together. And so we'll have 2 MnO4 negative aqueous plus 8 hydrogens aqueous plus 5 copper solids. And then that's going to go to, oh, I said 8, but this is really 16. Don't forget to multiply by your 2 by everything. And then that'll give us, on the product side, 2 Mn2 positive aqueous plus 5 Cu2 positive aqueous plus 8 waters. And the 10 electrons cancel on both sides. Now I wrote my 8 waters on the end just because lots of times you'll notice that that's how it'll be done, because the water's kind of like, you know, a little byproduct there, and usually most are worried about the Mn and the Cu. Does not matter the order though in any case. Okay, so now we're almost finished. The last step is to see, is this spontaneous or not? And to see if this is spontaneous or not, you need to go back to your redox table. You need to find your MnO4 up here. You need to find your copper down here. And you need to say, is the OA, which is all the way up here, higher up than the RA, which is down here? The answer is yes. And so because it is, we're going to write the word spontaneous on top of our arrow, which obviously I should have written longer. And then we're done. Okay, so that's example number 1. Now if we were to look at example 2, it's potassium permanganate solution poured into an acidic iron 2 sulfate solution. Okay, so you're going to do exactly the same thing. You're going to list all your entities. You're going to label them as OAs and or RAs. Find your strongest oxidizing half reaction, write it down. Find your strongest reducing half reaction, write it down. Balance the electrons, write out your net equation, then go back to this table and see which one's higher up, the OA or the RA. Is it spontaneous or non-spontaneous? And then you're done. Easy, right? Okay, so give some of them a try. We'll spend most of the class tomorrow doing them. By the end of the class, you should be good to go, because the only other thing I think we need to go back to is to make sure you got oxidation numbers down okay. All right, see you tomorrow.